Hello folks, welcome back to the channel. Today I am going to code a custom view in Kotlin. It's basically the same as like we used to code in Java and Android. We used to code a custom view in Android with Java. So basically what we had we used to extend the view class, then we want to override the onDraw method. Then I want to also override the onTouch event method too, so that it can be responsive to tap event. Yeah, and so basically what I'm going to draw is I'm going to draw like a circle, and I'll have some arrows, and the circle will as the circle will fill, the arrows will move up. Then as the circle will begin to fill, like it will as the circle will try to the fill movement, like the fill motion is like reducing or something, the circle will come down. So let's get started with the coding part. Class, I'll declare a class arrow by mover view, which will take context as a parameter. And okay, let me just check this thing out here. And let me have this here, which will take a context of the object as a parameter, and it will pass to the superclass. The mic here, just the mic here. So now we'll override the method onDraw. Keep it here and just move it a little bit down the mic. Yeah, so I have canvas method here. Just have to, okay. I've taken a canvas object into onDraw. We'll overwrite the onTouch event. Yeah, and it will return a boolean, and will return true at the end. Now I have a logic when the event.action is motion.event.action down. I'll have some logic here, and also declare a paint object. Okay, we'll take anti-alias flag as the parameter, and yeah, so for now the view is done. I'm just added to git. This is my path. It's called gtx demo slash UI experiments, Kotlin UI experiment, and I will add arrow by. I'll just add app. I'll say give a message that I'm adding the arrow by mover view. So yeah, so we'll have an object called arrow by mover, which will draw the arrow by mover thing, and it will also update it. So let's have that. So data class must have a, you must pass a parameter to data class. I'll pass x and y, and also something called scale. It will be 0 for now. It will be float. There's a typo. And here I will pass pad.float, package.float. Okay. Now we will also like arrow my pie mover will have two parts. One is the pie thing and another is the arrow mover thing. So let's code that up. Let's call direction arrow. Let's float the y float and var t float, which is a size. Um, and yeah, we'll have something draw method here. That is right. We'll have a draw method here where we'll draw the arrows. So it's basically we have to draw four arrows which will be like 90 to each other. The four arrows will be 90 to each other. Like we'll start from the middle and do 90 to each other. Save canvas store. Okay, I think we don't need x and y because we'll have x and y. We have already declared x and y in the arrow mover. We'll have var size and var w port. So w is the total width of the screen to which that arrow will move. Now we'll rotate it 90 degree. In fact, it will 90 of course. So if the first arrow will be 0 degree, then second will be 90 degree, third will be 180, fourth will be 270. But we also want an initial angle of 45 also. So the first thing will be 45, second will be 135, third will be something around 225, the fourth will be at 315. So it will be a bit tilted. Now we'll draw the arrow. As you know, arrow has a vertical line and two slant lines from the tip of the vertical line. So we'll declare a path first. Path equal to path. You can also have this particular type program language. You can also have path here. Okay, it's not an issue. Then we'll use move to and like line to. So move to will be 0 from 0 f to minus size. Sorry, it will move to will be 0 and 0. Line 2 will be path of line 2. Like we are drawing a straight line from 0 to 0 from 0 to 0 comma minus size. Also we can in fact instead of using path we can directly do this. Can also draw line 0 f 0 f 0 f minus size. Okay, and here another thing you can have is you have to draw the slant lines. So the lines are like we are translating to they are kind of like you can visualize as they are rotated 45 degrees from the tip of the vertical line, and they are like opposite to each other. So that can be coded in this way in 0, 2. So instead of having this things here, yeah, and also store. You have to translate to the tip of the line, that is 0f minus size by 2 minus size. Then here the first line will be around 45 degree, the second line will be minus 45 degree. So, or the first will be minus 45, second will be plus 45. Date is like 2 plus I minus 1 cos 45 f. So when it is 0, it will be minus 45. When it is 1, it is 2 into 1 minus 1, it is 1 into 45, that is 45. So then you have to draw a line. So it will be a vertical line which will be from 0 to size by 2, size by 3. Let it be size by 3 or size by 4. 0 2 0 size by 3. 4 will be better. I think 4 will be better. And comma print. So this will draw a slant lines from the tip of the line, tip of the vertical line. Now actually this will be translate. This thing here will be, this is okay. The problem is something will be around, will be translated. So this thing 0f to 0f, you will be, it will be like w cross w cross. You have to pass the scale thing also here. W cross scale and y will be w cross scale. So it will move to the top of the top, like top left part or top right part or bottom left part or bottom right part. So since it's already rotated 90 degree, so we can like visualize it as this way. So actually this is not the, there is some issue also. Now if we go this thing, you have to say, instead of doing this, we can just put in a translate thing instead of. Just say convert translate. Yeah, this will be fine. In fact, it will be 0 to w cross scale. Okay, yeah, this will work. Yeah, I think this will work. And I think w minus size will be the better way to say this, or it will go out of the screen. Yeah, and so this is the arrow thing, and we need the pi thing. So the pi will be filled like it will fill from 0 to 360, and it will go from 360 to 0. Now we'll have the pi, which direction pi. We'll have something called, we have already declared x and y, so we'll have something called radius or r, and then we'll say in fact instead of using class we can directly use like we can declare, we can pass the w and size and canvas and pen to it, and we can have a function to it, like we can create a function to it instead of this whole thing. But for now let us have this thing on yeah, we can do this, like instead of having creating all this creating all this thing, we can simply say, instead of creating class and all, draw arrow float. I'm trying another way to do this thing. This will be canvas. I'm declaring a lambda instead of all this stuff. So now if I have this thing here, now I have to have all this thing here. It will make sense. Now let's uncomment this line. So basically what I'm doing, instead of creating class, I'm creating a lambda. So now I'll comment out this and I'll call lambda here, draw phi. So scale is not declared here. So what I will do is I will have another float and say scale. Yeah. So instead of doing all this thing here, I'll say I'm declaring a lambda instead of class. So this will make much sense now. So I'll declare the parameters here: canvas, pen, uh, radius, and scale, and canvas or save. This will be a simple thing. We'll draw an arc, which will be this minus r to r to r. Then in the middle we'll have the declare the start angle and we'll declare the end angle. The end angle will be 360-degree cross scale, since the end angle will change to 0 from 0 to pi, from 0 to 360, then 360 to 0. This will be true. So this true, this boolean variable is also a very important thing. Like in an arc, like if it is if you pass that it must be centered to the circle, then it will draw a arc which is whose radius will like the endpoints will touch will meet the center of the circle or center of the arc. So now this style is fill. We'll have a circle also which will stroke it, and it's 0f to r paint, and we'll also have a color for it. Say blue. I'll copy a color here. I'll check color from macroUIcolors.com. I will select this color for now. Okay, so I've declared a file, and also I have to I have to set some color here also at this point. The arrow will be white color. So now we have declared the draw by lambda, draw arrow lambda. So what we have to do is we have to use them in draw method of draw by arrow by mover. It canvas print. Okay. So let's not have this x and y. We'll set the x and y as w by 2 and h by 2. That is device width and height. Then we'll say we'll also set the stroke width in math.min of w comma h by 35, and this is this is like just a random value. Like I want it to not to be as big and not to be very small, not to be very big and not to be very small. So, and I will set the stroke cap also as cap it round, and then I will draw. Okay, this cannot be accessed outside. You have to declare inside. First first we'll draw the pie. That is canvas, pass canvas, print, and I'll say radius is math.min of. Okay. So I will declare a radius here also. Like before in the class, it was an instance variable that is var float equal to math.min w comma h by 10 or by 15. So I have radius here. I'll pass the radius in this variable, and scale also. We'll draw arrow now. Then, so what are the variables for arrow? Plus spent, w size and scale. So w will be like math between of w comma h, and like another thing is size. So size will be like r. It will be r also. It will also r, and the other one is scale. So now we are done with this. Now we have to update the scale thing, which we will receive it from somewhere, from an animator most probably. Scale is something around. We'll set the scale here like this. The scale is going to scale. In fact, we don't need it also. Like we can manually call it dot the scale is this much. Now I have to handle tab. So I'll get the x and y from that event motion event dot x and motion event dot y, and I will check whether the x and y satisfy a particular condition. It will return a boolean. Actually, x is greater than this x minus r, and x is less than equal to w by 2. This is w by 2 plus r, and y is greater than this h by 2 minus r, and y is must be less than equal to this dot h by 2 plus r. So generally it is like so we are handling the tab for a particular reach, for a particular rectangle. So rectangle width is the rectangle is centered at w by 2 and h by 2, and its width is 2 cross r, and height is 2 cross r, and is centered at w by 2 and h by 2. So we are trying to find whether the x and y coordinate is within this rectangle or not. If it is within this rectangle, then the tab is inside this rectangle, and it will satisfy our condition. So it's generally not a rectangle, it's a square, to be precise. And yeah, so this is the method. This is our method, and we can remove this, and we can add it to Git. Okay. adding arrow by mover, and so now the view will not directly draw this arrow by mover. It will contact a renderer. So we have to code a render which will contact this view, which will contact the arrow by mover from the view, and it will draw it. So let's code the render part. Render is arrow by mover renderer. It will take a view as a parameter, and it will also update the thing. It will take a factor as a scale parameter from the animator, and it will update it. It will also update the view. It will update the arrow by mover, and it will update the view. Now we haven't declared like arrow by mover, so we'll update the view. Say it is view.post since we are updating from some other thread. Now we'll draw the thing here, or we'll render it. Okay. Now we'll handle tap, and so this will have a like it will have a render variable that will check will count the number of times the view is rendered or the thing arrow by mover we have rendered, and we'll have a arrow by mover as usual. As discussed, we'll have an arrow by mover. Okay, it will be null. Its default value will be null. We'll declare it when the rendered time it is rendered is 0, and arrow mover, and we'll declare something called W, which is canvas device width. Is also equal to the canvas width. So it won't be equal to device width or device height. It will be equal to views width and views height. So this will be to float and height to float. Okay. So we have got the views width and views height. Now we'll like pass this variables to arrow by mover. It is w comma h, and scale is 0. So we will only pass w comma h to arrow by mover. Now render is equal to 0. We'll update the value of render. We'll implement it for each time render cycle. Now we have declared the arrow by mover. Now we have to update it and draw it, and we have to also handle the tab. We draw canvas paint. Okay, and this thing will be arrow by mover. Update scale. We'll pass the scale variable to it, and now we have to handle check whether we are handling the tab in arrow by mover or not. Arrow by mover dot handle tab. Alright. So this thing will be so why it is giving us an error, because if arrow by mover doesn't exist, then we haven't taken care of what will happen to handle the tab. So we have to check. We have to give it a default variable. If arrow by mover doesn't exist, then handle tab won't exist. So it's default. So take the default variable as false. Then we'll do something. Most probably this renderer will then if check whether if arrow by mover is handling the tab or not. It will if it is handling the tab, then it will start something called animator. The animator will give us the scale variable, and it will update the view and the arrow by mover. So now we have to code that animator since arrow by mover render is done. So let us add the render to the git code. Adding mover renderer. Message wrong. We'll amend the message. It is say I. Okay. Now we'll code the animator. We'll say arrow by mover animator. We'll take the render as a variable, instance variable for the animator. Mover renderer. Okay. Now this will extend animator listener as adapter. So generally, if we uh, there is an issue here. So generally, if we, there is an arrow animator listener interface, and if we implement it, then we can access the lifecycle methods of for an animation. Now we don't need all the lifecycle method. We need a certain method which is called on animation end, which will be called when the animation has ended. During that time, only we want to trigger some event at that time. So we want only that method. We don't want all the methods. So what we have to do, we have to extend an adapter class. So adapter class has already implemented all the method. It has already like it has already implemented the interface and overwritten all the method. We have to call only a certain method. Okay. So not only that, so we will have a the animator will be the animator object will be a value animator. So value animator allows you to say it is called anim, and value animator, it allows you to animate from a certain property to another, from a certain value of a property, for a certain property it allows you to animate from certain value to another value. Like say you have a color which is red, you want to animate it to green. So what you'll do, you'll use anime value animator and animate it from red to green. Suppose you have a float variable, you want to animate it from 0 to 360. So you have to use value animator of float 0 to 360. So it will animate from 0 to 360, and it will give at each point it will give you a certain value which you can use as a value for your as an animation value at that point. And you can like render that property of certain view or some certain property of a view according to that value. So value animator, we need it to go from 0 to 1. So this will be the value of this scale. We have declared a scale here, the scale for arrow by mover. Okay, uh, this is the scale value of scale 0f. We know, you know, there is a method called update scale. So this from 0 to 1 f, what we have declared in the value enter, will pass it to this update through the renderer which I have already declared here. Okay, we'll pass it to, generally we'll pass this in this update scale float, will the scale variable will be will be within this 0 to 1 thing. And we'll also have a reverse anim which will animate the value from 1f to 0f. Okay, so all these values will pass to the update part of the renderer method. Now I will declare a method on animation date. It will take a value animated thing. So, and I will implement another, I will implement an interface called animator update listener. Okay, now it will give an issue because we have to override this, it's on animation update method. So generally if you do something called if you to create a variable here called factor and say you have vf dot animated value. So current value is object or any. Now if you say it is as float, it will give you a float variable within 0 to 1. So it can be 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5 or 2, 1. Okay, so this thing you will pass to your renderer object. Then renderer will pass that to alpha mover. Okay, you will pass it to renderer object. Now you need another, to override another animation end. We'll come to it later what why we'll use this. It will take an animator object you need to start the animation. Okay, so which animation you have to start, it will be monitored by a variable called mode. So when the mode is 0, you will start anim. When the mode is 1, you start reverse anim. Since the value of at 0, the scale value is 0, and you want to it to go to 1, and at 1, the value of reverse, the thing like reverse anim thing, like the value, the scale value is 1, you want to go from 0 to 0. So in fact, you can do one thing, you can like say on animation end, you can have something like mode or animation. So now we don't need to worry about it. We can change it to later like this way, because not this. We can change it to 0 or 1. We can change the on animation end. We'll change the value of mode. So it will be, if it is 1, we'll change to 0. If it's 0, it will change to 1. So the easiest way to do is this way. 0 like mode plus 1 percentile 2. So what we'll do is when it is 0, it will be mode will be 0, and it will be 0 plus 1 percentile 2, which will be 1. When it is 1, the mode is 1. So 1 plus 1 percentile 2 is equal to 2 plus 2 percentile 2, which is 0. Now this part, when mode 0 will start the ending the start, when 1 will start reverse ending the start. So these are not the only thing we have to do here. Another thing is like we shouldn't start if the animation is already started. So what you have to do is animating will monitor the value whether the animation is started or not with the with a certain boolean variable called animating. So if it is not animating, then only will start. Now on end, if it is animating, then only will end it. So if animating is also not required, I'm just doing for like readability of the code and all. So we'll set the animating as false. The animation has already ended when you're going to on animation. So these are not the only thing. So we haven't specified for now. We haven't specified like what will the listener for anim on updating when we are updating the anim thing, and what will be the listener for anim when the animation has ended. So we have to specify the listeners here also. So we'll say anim.add update listener, which will be this, and reverse anim updated listener will be also this, and anim.add listener. So this will monitor your on end thing, and reverse anim.add listener this. Okay, so wire render, and you also now you have, as you have created this thing, just add it to GitHub. It's adding animator. Another thing I missed is you have to say animating is true when you have started the animation. Okay, so we'll just add it again to the same commit. Okay, so now we are done with the this part, and we'll use the animator here. Animator will pass the render, which is this, and we'll start the animator on if we if arrow by mover is handling the tab. Okay. Okay. We'll start the animation. Okay. We have started the animation. Now we'll just add this part also to the same commit. Okay, so there will be some more part like now we can use the renderer from the view. So to use the renderer, we have to create a renderer object. It is arrow by per renderer. We'll pass the view object, that is this view object. Now we'll call renderer dot render canvas and paint. So we'll also have a background color that will be something called, so which will be a bit black. So I got a color from net, that is 2121. So we'll use color dot pass color. If you have hex string as a color, then you can use color dot pass color. Now we'll say whether the renderer is handling tap, which will indirectly call the arrow by mover thing. So this is of the view part. Now we have to create the view also. Create as it will have a okay. So there is some, we have to create a static variable, static function called create. To create a static thing in Kotlin, we have to use something called companion object. Then we'll have a static method here. It will take an active, this create method will take a activity thing as a parameter. So now we'll since you know activity extends context class, so passing activity as a parameter to the context will make sense here. Arrow by mover view activity. Now we need the device width and device height to set the views width and height accordingly. So what we have to do, I have a util class which will get the device width and device height as a point object. So say this is size, takes a, I will get a point variable which will take a activity. Okay, so this is a util class which I created. You can see the code here. So get dimension activity. Okay, so get dimension activity. I'll get a display manager from the context from the system. Then I'll get a display object. Then I'll declare a point, and I'll try to get the real device width and height in this point object, and then I'll return this point object. So now I've declared all this thing. I can just say activity add content view. Like I have a coordinate layout as a parent view, so I'll add this view as a child view. So I'm adding the view, and I have to specify the width and height of the view. It will be the width will be size dot x, and height will be also size dot x, which is a device width. Okay, then we'll add this thing to the git. So we'll have a separate commit. Using render, we are using render in a view. And creating a static create method. Okay, so now we'll come to the we have to create this thing in the activity. So it's simple. I will comment out the previous view, and I will say arrow by mover view create this. I will quit my Google Chrome. I've created the view. Now I have to run a emulator. What I will do, I have Motion emulator. Okay, so Motion is a lightweight emulator you can use. So I will start the emulator. To check what is my limit is taking. Okay, For now we have 2.31 GB, but we'll remove this thing. So it is opening the, it is starting, the Android device is preparing itself to start. uh, let's have let's, we have to be a bit patient with it. We have to be a bit patient with it. And alright, started. Let's start. Let's connect from Android. Let's connect from Android Studio to this Motion thing. So it is already connected, but yeah, it is showing us a virtual device called unknown Google Nexus thing. So I will just run it for now. So it is taking some time to run. So I think it's due to, like, it generally takes some time to install, like to build the project, and then to make to compile all its to a native package to APK, and try to go to the like emulator. So it's a bit, it takes a bit of time. So let's check for bugs. Like, I think there may be some bugs in my code. Yeah, this is the bug. I knew there was. Instead of I, it will be J. So the reason why it is not I was, we want to like change the width and height accordingly, and but here it won't be that it will be on the same line, or like it will also change to somewhere else. So it's taking a bit of time. I may do this. I think I'll do this in a separate video for now.